Hey everybody. So now we've moved on. Module 2, topic 1, but we're in this unit 3, triangle congruence theorems. Okay, and I think this is lesson 3 and 4. Here we go. 2 workspaces. Triangle congruence, triangle congruence. Okay, so first let's introduce it. All right, so side to side, side to side. And let's see what else it tells us here. So we better move our head. Okay, and this is all about what corresponds to what. Okay, so for example, YW is congruent to GN. YW to GN, see the 1 hash mark? WYNG. WYNG. Okay, what side goes to what side, what vertices. So one's going up, then the other comes down, one goes down, the other goes up. Cool. All right. However, not the correct way to write it. Then we have the corresponding angles. See how L has to go to R, W to N, and then it looks like a right angle Y to G. Okay, so it's talking about those. So this whole idea is corresponding. Okay, what corresponds to what? You see how that goes 1, 2, nothing? Then we're going to go 1, 2, nothing. Picture arrows. So triangle JXP goes from 1 to nothing, from 1 to nothing, CHD. So make sure you got your cap locks on, CHD. Okay. Now, if XJ goes this direction toward the 2, HC, so it's all about corresponding. CD, CD from 1 to 2, JP, PX, PX. So it's going from the 2 to the nothing, from the 2 to the nothing, GH. And J has to go to J is between them, so C. H is by itself here, 1 to nothing, so X. And P to D. That's the only one left. P to D. To me, I think we're done. So this is all about corresponding. Corresponding. Okay, now we're going to drag and drop. Drag and drop. LYLW is congruent to GRN. Rewrite the congruence into 5 different ways. Wow, wow. So the Y is first, then swap the WL. Yep, okay. And then the L's first, and then you got to swap those 2. And then the W's first, and you got to swap those 2. But as you swap them, you have to swap these. Okay. All right. So now BMQ, SPZ. Sort the congruency statements for the triangles and the sides and the angles. Drag and drop. Okay, so BMQ. We're going to flop Q and B. So Z to S, Z to the S, Z to the S. Okay, M goes first. MB, MBQ, PSZ. PSZ. BQM, B first, third, second, so around B or boom, boom. So SZP, SZP, QMB, QMB backwards, ZPS, QBM, ZSP, ZSP. And process of elimination, keep our fingers crossed. Okay, drag and drop each. Okay, BM, SP. QB, Q to B, Z to S. MQ, MQ, PZ. Wow. Does not complete any order of congruence. So I guess ZP, ZP, QM. Is it going to allow that? Yeah, see, they're not the correct order, so we're going to drag and drop, drag and drop, and drag and drop. Because the order is not the same. Drag and drop. So P, angle P goes to M. Q goes to Z. And process of elimination. So it's all about corresponding parts. Okay. Okay. Now proving side, side, side. Okay. After one reflection, R. Okay. Now consider VAR. VAR. 1, 2, 3. And BKF. 1, 2, 3. And suppose this is equal to that, that's equal to that, that's equal to that. 1 goes to 1, the 2 goes to the 2, and the 3 goes to the 3. Okay? Now, how would we show by mapping? Okay? Reflect and rotate. Okay? Reflect and rotate. Reflect and rotate to show that they're on top of each other. Okay. Now, analyze the work example, then answer the following question. Okay? After one reflection, point R. After one reflection, point R maps onto point blank, point F. Okay. After two reflections, so we're going to reflect and then reflect VR. VR goes to the B. Maps onto FB. AR to FK. AV, BK. Yeah, I'm going to think KB. Any point can be mapped onto another point in the plane at most. Any point can be mapped onto another point in the plane at most. Two reflections. Okay, that's fine. A perpendicular bicutter can be drawn through any two planes, reflecting across this onto another. So they're going to say 1. How does that make sense? There's two reflections here. Perpendicular, perpendicular. Any line segment can be mapped onto a congruent line and at most one reflection, I guess. I don't know why that is. A line segment can be mapped onto a congruent segment after one reflection, but not always. Because the series of reflections preserves distance and angle measures, VAR is congruent. This shows that the side-side-side congruence theorem. All right, now let's try it again. Okay. See the diagram, and this time 1, 2, 3, side, angle, side using transformations. So we're just going to reflect it. A series of 2 reflections. Okay, the point F prime can be at only 2 places on the circle because n prime must be congruent to the original NCF, MVR, MVR, angle N prime, C prime, F prime. Okay. Point M and F prime are equidistant from V, lies on the perpendicular bisector. M prime, F. M and F are equidistant from V. And V lies on the perpendicular bisector of R and N. RV, VR, perpendicularly bisects. That is why VR maps onto MF, lies on the V, lies on the perpendicular bisector MF. Because the series of reflection preserves distance and angles C and F. C and F, so it goes toward the 1, nothing, toward the 1, nothing, toward the 1, nothing is congruent. C and F, VRM. Suppose you mapped FC to MV. FC to MV in 1 or 2 reflections. Point must be on the circle R. N would be over here. If point N is not at R, then the reflection across the MV will map to point N prime. Okay, so we're flipping this. Wow. Quite the problems, aren't they? Mapping via transformations. Okay. So we're going to do the same thing. Okay. Reflect. Okay. FG is mapped onto side PQ with 2 reflections. Triangle FGH, F prime, G prime, H prime is reflected across the segment PQ and mapped onto PQR. Boom. FH maps onto FR. FH PR. Side blank of triangle maps onto QR. QRHQ. QR, G8, QR, GH. Therefore, we have angle, side angle. Introduction to triangle using sides and angles. Okay.